In the last lecture, we have studied about Epsilon NFA, and in this lecture, we will be studying about how to convert Epsilon NFA to its equivalent NFA. So here we have a question given, convert the following Epsilon NFA to its equivalent NFA. So here we have an Epsilon NFA given, and we know that it is an Epsilon NFA because Epsilon symbols are also used in this NFA. That is why it's an Epsilon NFA, and our task is to convert it to its equivalent NFA. So the procedure for converting any Epsilon NFA to its equivalent NFA is that for each state that we have, you have to check where does this state go on Epsilon closure, and then the set of states that you get here have to be checked on which state does they go on getting a particular input, and the set of states that you get here have to be again checked on to which states do they go on Epsilon closure again. Now, what do we mean by Epsilon closure? So Epsilon closure means all the states that can be reached from a particular state only by seeing the Epsilon symbol. So let us see, for example, if you are looking at state A, you have to see which are the states that can be reached from state A only by seeing the Epsilon symbol. So what are the states? A, it can go to A itself. I already explained this in the previous lecture that every state goes to itself on seeing the Epsilon symbol. So A goes to itself on seeing Epsilon, and on seeing Epsilon, A also goes to B, and from B on seeing Epsilon, it can also go to C. So without any other kind of inputs, only by using this Epsilon symbol, A can go from A to B to C. So the Epsilon closure of A will be A, B, and C. So I hope that was clear to you. So in order to convert this to its equivalent NFA, this is the process that we have to follow. So for that, let us first draw the transition for this NFA that we will be creating here. I have states A, where A is my starting state, and B, and then C. And the inputs we have are 0 and 1, because this is going to be the NFA. So now let us try to follow this procedure and fill up this table. So for example, now let's say we want to fill up this column. A on input 0. A on input 0, where does it go? So this is the state A, and you have to check where does A go on Epsilon closure, and also where does this go on input 0, and where does this go on Epsilon closure again, because we are checking for A on input 0, this one. So let's see, A on Epsilon closure, where does it go? The Epsilon closure of A are A, B, and C. I already explained that. So A goes to A, B, and C. These are where this A goes. Now on 0, where does A go on 0? A on 0 goes to A itself. And where does B go on 0? B does not go anywhere on 0. So this is phi. And where does C go on 0? C goes to itself on 0. So this is C over here. And now we have to again do the Epsilon closure of these states that we obtained here. A. What is the Epsilon closure of A? A, B, and C. So Epsilon closure of this A will be A, B, and C. And phi is nothing. And C. Epsilon closure of C. C on seeing Epsilon, where does it go? C goes only to C. So we obtain the states A, B, C, and again C here. So these are the states to which the state A will go on getting input 0 for our NFA. So here I will write states A, B, and C. Alright, so now let's do the same thing for input 1. The state is A, so we have to find the Epsilon closure, and then now the input will be 1, and then again the Epsilon closure. So A's Epsilon closure are A, B, C. We already found out A, B, and C. And on input 1, where does A go? A does not go anywhere. So A goes to phi. And on B, B on getting input 1, where does it go? It goes to B itself. Goes to B itself. And C on input 1 also goes to C itself. Now we have states B and C here. We have to do the Epsilon closure of them. Phi is nothing. So Epsilon closure of B will be B can go to B itself on Epsilon, and also it goes to C. So B and C. And C on epsilon closure, where does it go? It goes only to C. So the final state that we obtain are B, C, C. So that means B and C. So A on getting input 1 will go to B and C in our NFA. Alright, so now we have finished for state A. Now let's do the same for state B. B, for input 0, we have to check epsilon closure, 0 and epsilon closure. So B's epsilon closure will be B and C. B and C. And where does B go on getting input 0? B on input 0 does not go anywhere, so it is phi. And C, where does it go on input 0? C goes to C itself. And now this is phi, and we have to do the epsilon closure of this C now. Epsilon closure of C is only C, because C goes only to C on epsilon. Now the final state that we obtain is only C, so B on input 0 goes only to C. Okay, now let's do the same thing for B on input 1. Let me write it here. B on input 1, so we have to do the epsilon closure 1 and epsilon closure. So B's epsilon closure are B and C. We already got here B and C. And B on input 1, where does it go? It goes to B itself. And C on input 1 goes to C itself. And what is epsilon closure of B again? Epsilon closure of B is B and C. We already know B and C. And epsilon closure of C is only C. So we get B, C, C here. That means states B and C. So states B and C. Okay, so the last one is C, and I'll not be solving it here. I hope you know the procedure. So if you solve for C, you will see that C will go only to C even on inputs 0 and 1. So here we get the transition table for our NFA. We have converted this epsilon NFA to its NFA. But the question is, what is our final state? So here initial state is A, it's fine. But what are our final states? Here in the epsilon NFA, C was the final state. But in case of the NFA, what will be the final state? The final state will be any state that can reach the final state only by seeing epsilon. So look at this. A, only by seeing epsilon it can reach C, that is a final state, and B also only by seeing epsilon it can reach the final state C. So A and B will also be final states. A and B are also final states, and C was already a final state. So in our NFA that we have obtained, we have A as the initial state and A, B, C, all of them are final states. Now let us draw the transition diagram for this NFA that we have made over here. So we have state A, which is the initial state as well as the final state. So I'll give like this, and let me make state B over here. B is also a final state, so I put a double circle, and C, I'll make it here. C is also a final state, so I put double circle around C. Now A on input 0, where does it go? It goes to A itself, and also it goes to B, and also it goes to B, and also it goes to C, and also it goes to C on input 0. So is this possible? Yes, this is very much possible because this is an NFA. And on input 1, where does A go? On input 1, A goes to B, and also it goes to C. So this is on input 1. Okay, now let's come to state B. B on input 0, where does it go? It goes to C. B on input 0, it goes to C. And on input 1, where does it go? It goes to both B and C. It goes to both. Okay, this is C and also to B. So this is on input 1. And C, where does it go? On input 0 and 1, it goes to C itself. C goes to C itself on inputs 0 and 1. So this is how you convert an epsilon NFA to its equivalent NFA. I hope it was clear to you. Thank you for watching, and see you in the next one.